All right, welcome back. So the last lesson we talked about reproducible reports and using Quarto. We briefly touched on R packages and how to install them, what's the purpose of an R package, and then we talked through the components of a Quarto report, and then also a little bit of the Markdown customization options in terms of making things bold, italics, including hyperlinks, including images and tables and lists and so forth. So feel free to go back through that last lesson, go through all the supplemental material. There's a lot of supplemental material online related to Quarto and related to Markdown in general. Markdown is all over the internet. It's very, very standard documentation for Discord, for Slack, for GitHub. Let's see, what else does? I think Reddit does Markdown styling. Yeah, there's a lot of different social media networks will support Markdown styling for text. So it's a good idea to kind of get that under your belt regardless, but it's especially useful here because we're going to be using it to write our reports, write our homework, and turn in projects for this class. So that said, we want to get into this is as Hadley Wickham would put it. He's the author of one of the authors for R for Data Science. This is the cake, like the dessert of R. Like this is the material that makes people really, really excited to learn R. And I'll go through why. Number one, you can make some truly beautiful figures, like really, really beautiful figures in R. And then two, you have the ability when you're making figures with R, you have the ability to recreate them and modify them basically on command. I've seen some figures in Excel where in order to recreate the figure, you have to go through the point and click engines and you're just rebuilding this figure from scratch. And if something's wrong, you basically delete it and start over completely. With ggplot, because and ggplot is the R package, technically ggplot2 is the R package that's useful for building figures. We're using R script, or we're using a Quarto notebook or a Quarto document to build our figures, and so therefore we have a record of everything that we did. If we have to go back and make a modification, it's just a matter of scrolling up and changing the line that needs to be fixed. So the overview for this class and why what we're going to cover over the next couple of videos is we want to talk about what in the world a layered grammar of graphics is. So the GG part of ggplot is for grammar of graphics. We'll talk about loading a package. So we've installed some packages. We've installed the knitter package. We've installed the tidyverse package, but so far we haven't loaded them. So we'll get into that. We'll build our very first ggplot, and then we'll go in detail about the different components of a ggplot, like the aesthetics, the geoms, labels, facets. And then there's a section down here called organizing ggplot code. And this is very important because ggplots are built using a layered grammar. So that means that it is possible for code that happens later in your write-up to overwrite things that happened before, kind of like paint on a canvas. You can paint a mountain, but then if you paint something over the mountain, you could not see that mountain anymore. All right, so without belaboring the point too much further, let's get into the first section, the layered grammar of graphics. So I want to unpack the title, Layered Grammar of Graphics. We'll start with what a graphic is. A graphic is a visual representation of organized information. And so right here, I have a visual representation of information. This is information. It's not information that's useful to anyone, but it is information and it is visual. It's not organized. So this is technically like, this is a graphic in terms of like how people would normally talk about graphics. But in terms of computational data science, or just data science in general, we need a graphic to be a visual representation of organized information. And because it's organized, therefore there is a set of rules, and a grammar is a set of rules for how to organize information. when we learn the English language has a grammar. It often, in fact, most of the time, does not make sense. English is an atrociously difficult language to learn, but it has some semblance of a grammar. So we understand that we would say, I saw this happen rather than I seen this happen. So the grammar is the set of rules that allows us to help facilitate the communication of information. So we have a layered grammar of graphics. So graphic is an organized piece of is an organized representation of information. Grammar means that the presentation of that organized information follows a set of rules, i.e., it's still organized again. And then the layered part, so layered grammar of graphics. So layered grammar of graphics, yeah. Layering means, as I mentioned before, if I have a canvas and I'm painting on this canvas and I paint a tree, but then I paint a house in front of the tree, I could completely cover up the tree with the house. Now, does that mean that the tree ceases to exist? No, I took paint and I put it on the canvas. That tree is there, but it is behind it is underneath the layer of paint that is painting the house. And the same thing can happen here in our code. We could build part of a figure that is to put a tree on the graphic, but then later come back and add another layer that overwrites, or not even overwrites, just covers up the information that was there. So it's important to understand the layering aspect and to understand that the layers have to go in a particular order. So let's get into an example. And this is a toy example in Wickham's original paper. And we've got this question of if does changing C affect A, and is this mitigated by D? So what we would do is we're going to have to map. We have to create an aesthetic mapping from each of the data to the kind of information we want to represent on the figure. So we would map, so let's see, does changing C affect A? So let's see, we would put A on, we've got build a scatter plot of C and A, and then we've got shape affected by D. So we're assigning different mappings to our figure. We're going to say, okay, well, I'm going to put A on the x-axis. I'm going to put C on the y-axis. And I'm going to assign the grouping variable or the mitigation effect to be the shape axis. Now, this kind of sounds weird. Like if you're like, hold on, I'm familiar with the x-axis, the y-axis, and the z-axis. What is a shape axis? Okay. So this is an axis is really just a way for us to display a dimension. Now, we are used to the idea of dealing with the real numbers, where the dimension of the real numbers is the entire real number line from negative infinity all the way to positive infinity and every possible number in between. But what if I have a dimension of just true and false? Then the dimension would be spanned by the numbers 0 and 1, and that's it. I could have information at 0, and that's the answer is false, or I could have information at 1. The answer is true. It doesn't make sense for something to be -3. What is that, 3 times more false than false? We don't know. That doesn't make any sense. It doesn't make any sense for something to be 0.7. Is that 7/10 true and 3/10 false? No, it's either true or it's false. Okay. The light is either on or it's not. So in that instance, we have a dimension represented by this information, whatever it is. In this case, we've got, well, whatever this D dimension is. The only two options are A and B. And so in that case, we've got discrete data where maybe there's an ordering, maybe there isn't. We don't know. Is A bigger than B? Is B bigger than A? It could be an unordered space where it's just these two quantities. There's A and B, and one of them does not come before the other. In that case, it makes a lot of sense to not represent this information with numbers, but instead to represent this information with something else, such as the shape of a point or the color of a point to say, okay, well, A is represented by blue and B is represented by red, or A is represented by triangles and B is represented by circles, something along those lines. So we're going to map this data. So we've figured out, we've got our data set, and we say, okay, well, we're gonna map this, and we've got and here's the thing. This is the real data. The actual data values 2, 1, 4, and 9 go right here. But where does it appear on a computer screen? And then this would be the pixel value. So this would be 25 pixels in the X direction. This would be 0 pixels in the X direction, 75 pixels in the X direction, and 200 pixels in the X direction. This would be 11 pixels in the Y direction, 0 pixels in the Y direction, 53 pixels in the Y direction, or 300 pixels in the Y direction. And once we have this mapping to say, okay, well, this piece of information, the data point 2, 4, gets mapped in pixels to 25 pixels to the right of 0 and 11 pixels up from 0. Then we would say, okay, well, what shape goes there? And a circle goes there. So this gives us a layer of the data. This is the aesthetic mappings, okay, where we've said, all right, well, we've got X over here, or let me see, the feature A over here. We've got the feature A, and we've got the feature C, and the shape of the points is governed by the feature D. Now, this isn't enough. It is showing that there's some sort of relationship, but we can't see from this the magnitude here. So we need to be able to measure these data points. And in order to do this, we have to have a scale, okay? We need scales. So that's another layer. We need to say, okay, well, we've got the scales here. We've got the geometric objects here. And then once we add them all together, and I do mean add, so we would start with sort of like an empty canvas, something over here, and then draw scales on it, and then draw points where they belong on the scales. So one layer at a time, we're adding them together, and then we would end up with this figure right here, where we have added the different components of a ggplot together, one at a time. And I want to say right here, when we construct figures, we often take for granted the complexity of this task. This is an entire branch of research in psychology that deals with how human beings interpret visualizations. And there's also different areas in computer science about how there's a branch of computer science, I believe it's called human and machine interaction. And it's all about how can a human and a computer have an exchange of information that's meaningful to both parties, so that the human tells the computer what to do and the computer can understand it, and then the computer returns a result to the human, and the human can understand the result that the computer yielded. So with that said, I think this is a good place to pause. We'll pick up next time with loading an R package. All right, see you then.